All right. Today we are going to talk about periodic trends. Sorry, I have a cold, so please understand that. First of all, we just need to go over the SPDF for now. This is about the orbitals. So 1s, 2s, 2p, 3s, and so on. This matters because this kind of give us like idea of shape of an atom or the particle, because not all the particle will be the circle as we think, because if you, if you ever like took any of the chemistry class in the school, you'll know that teachers will most likely going to draw like a Bohr model where you just draw the circle, 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 like showing the energy level. But that's actually not true. And um, for example, Heisenberg's uncertainty principle disproved it even. But it is widely used still because it is easier to understand. But anyways, this is like there's four parts in this blocks. One is S, two is P, and the third one is D block, and then F. So for now, for example, let's say like this is about the electro configuration also. So for example, here's the helium, right? Uh, Second element. The electro configuration for helium is 1s and there's 2, right? So 1s2. That's it. Okay, let's become more complicated now. Um, Fluorine here. So among the P, it has one, two, three, four, five, right? So it should be 1 S2, 2 S2, 2 P5. That's fluorine. Um, all right, now let's go to the shape here. So this is what it means by the SPDF. S groups are like this circle or this sphere, like just like a ball. And P, it's like a dumbbell kind of shape, if you like to say. And D is basically like this, and F, it's like that. So why does that kind of shape created? This is because of like the force between the electrons. Okay, moving on. Electronegativity and ionization energy. So electronegativity is the concept where it answers which elements can attract the electron stronger. So, there will be like something like hydrogen, and there might be another elements like fluorine, let's say. Not like every elements or like two elements will have like a same kind of strength, right? Strength of pulling the electron to contain the shape of the atom. So that's why the concept of electronegativity have um have come up, and that is closely related to the ionization energy, which answers how easily can we remove electrons from the element. So, ionization energy, when we trying to pull the electron out of the atom or the particle, there should be the energy to pull out because the nuclear, which has the plus charge, will attract or will pull the electron, which has the negative charge. So, like stronger electronegativity, that can also lead to the higher ionization energy. All right. So I previously mentioned about like periodic trends, and here's what it is. So for both like electronegativity uh and the ionization energy, it increases as we go up and go right to the periodic table. So when you see like up, like when you go up, the upper one has like bigger electronegativity and greater ionization energy. So for example, what I mean by this is that there's the potassium, this K here, and then hydrogen, which is H at this top. Which one will be um, have stronger electronegativity and greater ionization energy? Because hydrogen locates higher than the potassium as terms in terms of location in periodic table, hydrogen has the stronger electronegativity and greater ionization energy. That's pretty much it. And I'll upload some links that you guys can see like how does the orbitals that I mentioned as PDF orbitals and where I got this kind of pictures. So check it out and you'll understand better if my explanation doesn't help. Thank you.